Laba diena, maybe dobré ráno if it's in the morning. Because dobrý is like laba, I think, I guess. Well, I have now 50 minutes in sentence about, because okay, this is called workshop, so it should be a little bit more practical from your side, not just me speaking. Of course, it would be great if I bring some measurement, but it's not very convenient to transport measurement. So it will be more about thinking. Thinking of the box. First of all, I would like to give credits for inspiration to Irina Božáková, who I mentioned her already yesterday. It's really a very important and significant person in physics education community in Czech Republic. And he is responsible for Heureka project I was mentioning yesterday. She has several medals and prizes from European Physical Society and also from Ministry of Education of the Czech Republic. And she gave such kind of presentation, not identical because I made some modifications at the GREP seminar 2 years ago in Ljubljana. And so I will try to tell you something. Of course, thinking of the box you can find in Wikipedia quite a long description. Generally it means thinking non-traditionally in non-usual way. In Australia they say thinking out of the square, so but thinking out of the box is probably the American origin for that, like some symbolic idiom, and it means that something like making some puzzle, solving a problem which is not traditional, non-standard, or it may be something I know as a parent. For instance, if my daughter was at a primary school, she sometimes came to me to help with math problems. And the problem was that for me it was quite easy to set some equation and to solve it. But at the level of my daughter it was not possible to use equation, because that was not the level of math they were supposed to use. So there must be some another way how to use. And for me it was difficult, because I'm just straightforward to equation and to solve it and to find solution. But I was asked to find some different solution. So that's what is meant to think. Sometimes it's used in connection with creativity and so on, but it's quite a broad and wide topic, and I will try to be more specified on this part.
Could you cut in some parts, because colleagues asked for me to translate?
Okay, if you, I think maybe if you like, because I think it's better to make it shorter. Yeah, so please.
Tai kaip supratot, čia bus praktinė veikla apie tai, vėl kaip mąstyti iš dėžės, čia mes neturim tokio pasakymo, kad tiesiog galėčiau išversti, bet vėl angliškai to out of the box kalbam, tai jisai pavyzdį tokį dabar labai gerą pateikė pirminį, kaip jis pavyzdžiui turėjo išmokinti savo dukrą išspręsti tam tikrus matematikos uždavinius. Aišku, jisai čia kaip fizikos profesorius, tai iškart gali ten viską spręsti su lyčių sistemom, sudėtingom ir taip toliau, bet vat ir tokioje atrodo paprastoje situacijoje jam teko, pavyzdžiui, čia kaip tas labai geras pavyzdys, sugalvoti būdą, kaip nenaudojant tų sudėtingų metodų paprastai dukrą išaiškinti. Jisai dabar bendrai pateiks daugiau tokių pavyzdžių ir mes kažkokį praktinę veiklą darysim.
Okay, thank you. In Prague they have even a seminar for future physics teacher, and again the aim of the seminar is to get also the students who are trained in integrals, in high mathematics, to come back to problems which require some different kind of thinking or approach. And so the math involved in the problems I will present is not over the certainty as math. So it's really simple, but sometimes it needs some different view. And also for university, I think my colleagues at the Department of Geography did very dangerous experiment, I would say. They took problems from entrance examination to university and they gave the same problem to the final year of university students after 5 years. And what you would guess? What were the results? The results of the at the final stage of university for the same problems was worse than the entrance problem, because they were trying to solve different problems, think different ways, and now they were asked to come back something like to a different kind of problem. So that's another point of view why to do. If you would be interested to look for such problem, there is an international competition. I guess maybe some of you know that. It's a kangaroo, original, it's a mass kangaroo competition. We have also in our country science kangaroo competition. Unfortunately, I'm responsible for the physics program in that. That is, I just saw a statistic that Lithuania participate in this competition longer than, for instance, Latvia, which is interesting. This is just a statistic at the page. So, and you can identify the COVID years in the participation as well. So that might be a source, one of the sources of the problem. So, and now it's time for you. It depends on you if you would just use some sheet of paper or if you just sing in hand. So maybe you could translate so that it's clear.
Tai pateikiu įdomų tokį pavyzdį, kad stojant berods, jeigu gerai išgirdau, į geografijos studijos buvo studentams duodamos tam tikros tokios užduotys, kur irgi reikėjo mąstyti iš dėžės, tai out of the box. Ir po to, kai jie pabaigė studijas, vėl davė atitinkamas užduotis. Tai nebūtinai buvo pabaigus studijas tų tokių reikalaujančių platesnio mąstymo užduočių įveikimo rezultatai geresni. Tai todėl atsirado toks bendresnis požiūris, ką reikėtų daryti kitaip, kad tas mąstymas būtų kūrybiškesnis, platesnis ir taip toliau. Tai čia aišku būdavo pirma užduotis tokia klasikinė. Jau galbūt daugelis mokytojų matė esate, reikia paimti ir sujungti visus taškus. So we have to draw without raising the head.
Yes, just continuously, not raising your pen or pencil. This is quite easy, you can find it on Wikipedia, this one, also the second one, and then there are some, so this is just starting problem.
Which is one of the classical ones.
So has somebody a suggestion? Yes, that's it. So, that is, you can just go, for instance, this way, or you can go just this way. Sometimes the problems have more solutions, so so this is really just a starting point. Now, a little bit, but not much, but a little bit more difficult, just 4 lines, not 5, but 4 lines, without rising and here I will put some hint. Now there is a hint at the bottom.
Čia rašo užuominą, kad neužmirškit, kad lapas neužsibaigia ten, kur taškelių užsibaigia. Čia tiesioginė prasme reikia mąstyti iš dėžės.
Has somebody suggestion how to do that? Yes? Just 4. Just 4, not 5. 5 was the first one. Now we are at 4. And just look at the hint. The piece of paper is large enough. That's the thinking, because we are naturally bound to something, but the piece of paper is large enough.
She's able to make it in 3 but not in 4.
We will come to see. Okay, when you would like to see this one or two of the solutions, please tell me. Yes. And thank you for your cooperation, because that was the purpose of the workshop, not just me talking, but... Yes, exactly. That's it. One of the solutions. Great. Thank you. So these are possible solutions, and as I say, that's the reason we are usually bound just to this square where the dots are. But now the solution needs that we go out of the space of the dots, so we can reach this. So. Now another variant. Now they are not just points, but small circles. Not points, but small circles. You see bigger circles, and now just 3 straight lines.
Dabar ne taškeliai, ir tik 3 linijos. Ne 4, o 3 dabar.
Now you know that it's not necessary to be just... I can of course share the presentation if you like.
So it has to be continuous.
Well, 3 lines continuous without raising pen and pencil. Yeah, that's Now you know you can go out of the square because it's the same problem. But now the difference is we have larger circles, not just points.
Čia dabar ne taškai, o jau skrituliai, tai reiškia plotas kažkoks yra.
Straight lines. We will come to those later on. But now straight. Yeah, that's the solution. Really, the hint is there are not points, there are some areas. And what you need is just to cross the area, part of the area. So, not to be fixed to the centers.
Ne kaip koordinatai taškelių plotais, užtenka kirsti. Bet kur. Jums užuomina Zoro filmą prisiminkime.
Yeah, I think you are on a good way. Don't be afraid to go out of the square. You can use the whole paper. And remember that necessity just to go across the surface, not through the centers. Let's just Yes, that's it. I think you got it. That's the idea. Okay. That's it. I think that was your idea, wasn't it? That was your idea, wasn't it? Yeah. So now the difference is that they are not points, but so again, you see that we are usually bound to the centers of the points to go, but now the point is somewhere different because there are small circles. Okay. Now let's back to points. Small dots, again 9, and we should connect with 2 lines with only 1 stroke. 2 lines. Just read very carefully the difference.
1 word is missing.
Yes, there is 1 word missing. And my practice is, because I'm also serving for Physics Olympiad, sometimes it's very difficult, we must be very careful to formulate the problems. Because especially clever students, we of course have the idea of the solution and how it should be, but sometimes they say, well, but you didn't ask for that, it might be different. So sometimes it's even important to think, when we are formulating problems for students, to notice what's the question, what we are asking, and what we are not asking. Because sometimes they say, "Oh, that was not my problem. It was not what you want." So now, really, the difference. But I think you got it. It's one word which is now missing about the lines. And now it's many solutions. For this variant, there are with one straight line it would be a problem, but now I'm saying it's just lines.
Just lines, not straight.
Great, that's it.
Gali būti nebūtinai
Nu, bet čia jau rogas kėl.
I think that's one of the solutions. There are many solutions. Yes.
Nu, kaip išsprendėt problemą?
But you could go with another third.
Yra tiesiai panašiai.
Okay, I think there is already one of the solutions. There are many solutions for this. So as you realize, now there is a missing the word straight lines. There are just lines. So you can just take any curve which go. It could be possible even with one curved line, but if two, that's maybe another option. So you want two, then raise your pen again, you can continue with the second or start at some other point. So this is again, and it's sometimes at least in physics problems, it's important to have all those important words in formulating questions and problems, because sometimes one word missing or one word extra might change the problem. So that's the solution. And now, not to bore you with the 9-point problems, go back to 9 points and with one straight line in one stroke. Now it's really out of the box. Just open your fantasy what you could do.
Viena tiesi linija, vien kels.
Yes, one and straight line again. But now really open your fantasy what you could do.
Can we cut the paper?
Yes, that's one of the ideas. You can cut the paper and to make a straight line and do that. Great. Yes, you can fold the paper and sometimes to do. You can take not a pencil but a brush, a thick brush, and you can do it with. So now we come to many possibilities. So I guess you are boring with 9 dots problem. So let's come to a different different kind of problems. Thank you very much for your great cooperation. So these are the possible solutions. And just a summary, the first start was simple, it was just 5 lines. Then there was necessary to think about larger areas, the size of the dose, and now the last problem was really very open, what you can do with those. Again, this is also quite well-known problem. I took the variant which is in, I think, a very interesting book written by psychologist Daniel Willingham, which was translated into Czech. Why don't students like school? I don't know if somebody of you read it. We have now Czech translation, so for me it was easier to read this. And now what it is. There is a rule that if there is a vowel on one side, then there should be even number on the other side of the card. So you have 4 cards, both sides of the card, and there is a rule, if there is a vowel on one side, there is an even number on the second side. And now you are asked to turn just 2 cards, not more, just 2 cards, to check whether this is fulfilled for those 4 cards. And now the question is which 2 cards you should select to verify. If there's 2.
Tai jeigu yra balsė vienoj kortelės pusėje, kitoj pusėje bus lyginis skaičius. Ir jums reikia parinkti šitų 4 kortelių, kurias 2 reikia atversti, kad patikrintumėt, ar atitinka taisyklę. Jeigu yra balsė, tai kitoj pusėje lyginis skaičius ir reikia atversti 2 korteles, kad įsitikintumėt, kad čia jos gerai sudėtos ar ne. Ir reikia pasakyti, kokias 2 kortas reikia atversti patikrinti.
Thank you for suggestion. Don't be afraid to suggest, because on average, in all population, on average, I think the first one was done in America, 50% was wrong. Well, we are all probably agree with the first card. That's A. I have heard that's clear because, but then this question was the second card. That's one suggestion.
B.
So we have all possibilities. So quite often to say is 2, but the right answer is 3. Well, the reason is, and that's again our general temptation to verify. But it's not said that if it's an even number, that it's the only possibility to have in one that must be a vowel on the other side. That's not the rule. The rule is when there is a vowel, then there is even number. So that's the rule for implication. So what we need to verify is 3. Because if we turn 3 and we see vowel, that's bad. That's the wrong possibility. So we should check this possibility A. That's I think clear, and we all agree that A is that's the one direction of implication in the logic. But then we should turn 3 to verify if it's not, because it doesn't say, the rule doesn't say that if there is an even number of cards, then the second must be vowel. It's just one direction implication. So that's it. Now, in the book, you have a similar problem. So that's the solution. A similar problem that you have rule that if you are allowed to drink beer, then you must be 21 or over. It's an American book, so maybe we have rule 18. I don't know in Lithuania, but let's keep. I think it doesn't matter even with 18. It would work. So now you have this situation: 1 card beard, and on the other side there is an age of the person, and you should check that if the person is drinking beer, it's over, let's say 18. I don't know what's the Lithuanian. 20. So let's say 20, according to have your context. So which card you would turn?
Only 1?
2 cards. Again, 2 cards.
Jeigu žmogus geria alų, tai jam turi būti 21. arba daugiau. Tai vėl reikia atversti 2 korteles, kad patikrinti, ar gerai sudėtus. Kurias 2 reikia atversti.
And imagine you are not seeing the person. You just have the card, because if you see the person, that's clear. That's no need to turn on the card. So be it, yes, that's clear. That's like the A possibility in the previous case. We should check when if somebody. What's the second card?
7.
Exactly. And realize that the same problem like the previous, but this is much more easier, isn't it, for us, because we know the context. It's not so abstract like turning cards and vowels and even numbers. This is something we are used to check. It's something which is quite natural from our life. So it is much more easier in this case, but they are the same cases. In fact, the principle is the same, but in this case, it's quite clear for us in this context, because of the context we know. Now, again, another problem like 3 packs and 3 rings. So we have 3 packs, and our task is that there are decreasing sizes of those packs. Our task is to transform this from that, but it's not possible to put larger ring to smaller ring. We must always keep the order that the larger is at the bottom and the smaller is at the top. So how to transport them? So we get this at this side. And we have those 3 packs. So we can use this, the middle pack as well to help that.
So what's the aim?
What's the aim is to arrange those rings in this order at this 3rd pack. But we can just move 1 pack, not to take them all at one side, but gradually one, another, a second. And on each pack, we are allowed to have the order from larger to smaller pack.
How many steps we can make?
It's not restricted.
Galima judinti tik tai vieną ritinuką. Galima padaryti taip, kad didesnysis turbūt
So, it's not restricted, the number of steps. The important is that you have always larger ring and above is smaller ring, not on the contrary.
Galim kelti tik tai vieną.
Ne, aš taip
You have solution? Oh no, not to that. It's a great example of thinking out of the box, yes, because we must be prepared that our students sometimes find some solution and say, well, it's possible, you didn't say it's not possible, but not just turning and rotating the packs, just from the pack 1 to the pack 3, not just rotate the situation. But the result should look like, yes, but not.
Bet mes kelti galime kiek norim kartų.
Nesvarom, kad
Aš vis tiek man reikia 2 rankas. We can use
twice? No. You always take one, put somewhere, and then you take another. Great, you are really thinking out of the box. That's a creative thinking. But, and you see how bad this is formulated, because you find other possibilities that I should put not this, so that it to be clear. That's the problem. Sometimes problems in physics Olympiad are very ugly to read, because we try to put all the content, not this, suppose this, just to be clear that the students are doing what we want. Yes. So is some idea? Yes. Great. You got it. And you got it exactly like an algorithm. That's the solution. You put A to 3, then B to 2, A to 2, then you say 3, C to 3, then A to 1, B to 3, and A to 3. So that's the combination. Great, you got it? Now, very briefly, because I think it's just a command, in the Willingham books there is another task, which is about Himalayan villages and their some tea ceremony with the rules. There are 3 acts, like stoking the fire, fanning the flames, pouring the tea, and then there are 3 levels of person, and there are some tasks are ordered like according to nobility. This is the first, and this is the last. And then some person can ask the other person to do some of this, but he cannot ask the more noble person to do the lower level task. For us, I will not solve it, but this is an analogy to the problem we have before. So we can take it like this. And now you know the solution. But for us, and it's an example given by William, for us this is quite a difficult task. It's no different with the beer, because we know the rules for the beer, it's a context we know, but this is a context which is not very known for us, so for us it's very difficult, though the principle is just like 3 packs and 3 things. Okay, let's go to some other problems. Because I have just 10 minutes and I have a small gift for you to solve. So just other examples. It's a physical example. The swimmer swims a 50-meter pool. One pool takes 1 minute. That's nice to calculate. And he swims 4 pools. And now our task is to draw the graphs for this motion. And probably 2 variants of graphs for this motion. Just a single while.
Ir reikia nubraižyti grafiką, prašyti tam judėjimui. Ir parašyti, aišku, daug variantų. So you would like them to draw the graphs now?
Draw the graphs, at least one variant, and think for which questions this variant is better. Because I will show you 2 variants, 2 possibilities of the graph, and each of the variant is more suitable to answer some questions about the motion.
Tai pabandykit nubraižyti grafiką, aprašant tą judėjimą.
So is some great? Yes, that's one possibility. Just minutes and meters. Yes. It's convenient to use minutes, not seconds, because it's okay. We have one variant. So you got the first variant. So this is just straight line. But when we are giving problems in physics Olympiad, we sometimes want students to draw it in this way. Because it's going through the swimming pool back and forward and back and forward. So this might be another possibility. And now we should think what is more suitable for some question. So this is probably much suitable if I ask how many meters he has at 3 minutes or 2.5, how far he swims, or for average velocity, which is now calculated quite simple. It's 50 meters per 1 minute, so we could transform it to standard values. But this is again more suitable if we are thinking about is it going forward or backward at what stage, which stage he is. So you see it's one graph, but more possibilities to do. And now the next part would be for students to draw a slower swimmer. Let's say a swimmer that takes just 25 meters per minute. How it would like.
Is there a possibility of drowning or?
No. It's a safe experiment, safe problem. No harm. So with the slow, of course, if with half velocity, we will have just this line, and of course this is except just it depends on the velocity. I just took 1/2, so it's easy to imagine. Okay. This is idea you can think maybe after the workshop, or maybe when you are at home. It's a little bit math problem. So you have a triangle. It's from Math Kangaroo competition, some old version. And you have two circles. Circle which is inscribed, and circle which is overscribed the triangle. And you know the diameters. It's a right angle triangle, so that's some condition for this diameter or radius of this. And now you should find a function how to calculate a plus b, which is a one side and b other side, and to find the result, to express them with this radius and this radius. It's a nice example on symmetry. So you can think over in that. While you are thinking, I've promised, hopefully I have enough, because one of my colleagues says that from a good workshop you should really bring something away, or to take away. So here is something for you. Hopefully it didn't mix during my flight, so that's just you know Czech. It's thank you. So yes, you may.
Čia apibrėžtinis ir įbrėžtinis apskritimas. Aplinkui statų į trikampį. Ten pasakys right angle, tai ten 90 laipsnių trikampį. Tai jeigu ten 90 laipsnių, reiškia remiasi tą trikampį į žambinę, tai ilgoji kraštinė į skersmenį. Ir dabar reikia sugalvoti funkciją, užrašyti a plus b, reiškia tiem trikampį statiniam, statinių ilgį sudėjus per šitą d mažą ir d didžiąją. Tai d mažoji dabar nematu, kur yra. Mažojo apskritimo skersmuo ir d didžioji didžioji.
O tai šitie pareiškia.
Čia dar paaiškins.
Hopefully everybody and you have scripts, and I will show you. Well, if you are looking for it, that's quite a nice solution. So you can think about it. It's quite simple with symmetry. And now there are some examples. If you want, I will share my presentation. And now a cube. It's not my invention. It was invented by a colleague, Alena Šarunová from Charles University of Prague. And again, if you would like to do that with your students, please write me just and I can send you this original part, which can be just cut along those full lines and bound along the dashed lines. And your task is to construct such a cube from that, so that at each corner the same symbols meet. So at each corner you should have the same symbol. So that's the task. That's another possibility how to think with that and work with hands. Okay. Really, if you like the original, just please send me an email and I will provide you. I did a whole presentation and also the start for this. Okay, thank you for your great cooperation. I hope you enjoyed it as well as I enjoyed it. And sometimes let's try to think out of the box.